We're going to solve linear inequalities. So first of all, let's just imagine that you're just going to write down every single number that's less than 10. All right, ready, go. 9, 8, 7, but what about the negatives? What about all the irrational numbers? Right, there's just too many to list. So this is where we need inequalities. So if I was trying to actually say all of those infinite number of possible values less than 10, you would just say all of the x less than 10. So that's where we need inequalities, when there's an infinite number of solutions. Okay, so let me show you also how to graph these. If with the one we just did, x is less than 10, we can show that on a graph by saying 10 is not included, and then 9.99, 9.5, 9.1, 8, everything in between. So it starts being all of those numbers. So on the graph, you would just show that as an open circle at 10, because we're not including 10, and everything less than that. Okay, and then if we're including 10, what we do is we just close in our circle saying that 10 is included, and then all the numbers less than that. So that line is representing all of the decimals and all those possible values less than 10. All right, and then at anything greater than 10, we go this way. Just note here in English, a lot of times we'll say like, you could spend a maximum of $10 on your lunch or whatever. So that would be an example of less than 10. And then here, when we're saying I want to have at least a score of 10 out of 10, on a quiz or something, that would say 10 would be perfect, and getting extra credit, anything higher than 10 is what I want. All right, so there's our inequalities. And now let's see what happens when we add and subtract, multiply and divide numbers with inequalities. So what happens, let's say we have something that's true, 5 is less than 10. And notice that if I took and added a number to both sides, my new result, that's also true. It turns out that you can add numbers, you could add, you could also subtract. We could subtract 5 from both sides, and what you end up with is also true. So we can add or subtract. We can also multiply or divide by positives. Here, if I multiplied both sides by 2, I would get 10 is less than 20, which is still true. I can divide by 2, $2.50, right? That's less than $5. But what happens is if you multiply or divide by a negative, it doesn't end up working out. So when I multiply by a negative 2, I get something that is false. Oops. Okay, so in order to make that work, when I want to multiply by a negative, what I'm going to have to do is just change the direction of that inequality. Okay, so if I change the direction, then what I get is something that is true. What would you rather be in debt, $10 or $20, right? Negative 10 is in fact greater than negative 20, so that is true. Okay, so when we multiply by a negative, also when we divide by a negative, so if I start off with this and I divide, say, by negative 5, any negative number, I would get negative 1, negative 2. Unless I change the direction there, it's not going to be true. So you have to change the direction when you multiply and divide by negative numbers. Okay, so you can add and subtract all you want, but it's when you multiply or divide by a negative number that you have to change the direction. Okay, so not true when you're subtracting. Subtracting's fine. Dividing is fine by anything positive. It's just when you multiply or divide by a negative that you have to change the direction. All right, so let's start working on solving inequalities. So the process is going to be just exactly like a regular equation, except if you multiply or divide by a negative, then you need to change the direction. Okay, so we just need to keep that in mind, and other than that, it's just like a regular equation. Okay, so I'm going to get all my numbers on one side, subtract 7 from both sides, and I would have 6x is greater than or equal to negative 24, and then dividing through by 6 here. I can divide all I want, right? It's only if I was dividing by a -6, okay? So x is less than negative, or greater than or equal to -4, and then I can show that on the number line. We can include -4, so I have that closed circle, and then it's all the infinite number of possibilities greater than that, so I would just show that with a line greater than -4. Okay, let's try another one. We can move x's as well as numbers, so I can subtract 7x from both sides, and I get -1 is less, or -1 plus x is less than 2, and adding 1 to both sides, we would get x is less than 3. Okay, so we can just show this open number line, just showing that key point of 3. I don't want to include 3, so I have this open circle and then everything less than that. All right, I'm going to go and show 2 more, and then I'll give you a chance to do a couple on your own. Okay, so here I'm going to divide by a -2, and because what I'm dividing by is negative, I need to change direction of that inequality sign. Okay, so I'm going to go R, and it used to be greater than, but it's going to change to less than. -12 divided by -2 is 6. So there's my answer. R is less than 6, so I just show that key point of 6 with the open circle because it doesn't have an equal, it's just less than. And my arrow going down to the left, everything less than that. Okay, next on this one, let's go ahead and simplify 5x minus x. That would be 4x plus 2 is less than 7x minus 5. And then I'm going to get all my x's on one side. So I can subtract, that's fine. That doesn't change the direction. Let's see, we get -3x plus 2 is less than -5. Get all our numbers on the other side. I'm going to subtract 2. So I get -3x is less than -7. Okay, be careful here because now I'm dividing by a negative, dividing by -3, so that I need to change the direction. It would become x is greater than a positive 7/3. And then we would show that on the number line with this open number line. 7/3, don't include 7/3, so I have that open circle, and then the arrow going off to the right. Okay, great, now it's your turn. All right, go ahead and pause the video and see if you can get the answer on these, and then also show that what the graph looks like. All right, first step, if you did this right, way to go, getting all of the variables on one side and getting, whoops, that's a 3, getting the numbers over on the other side. Okay, so let's see if you got to that point. And now let's see what your graph looks like. Go ahead and finish that one up. So we should have t is less than 3, and we'll have that open circle at the 3 because it's just a less than, there's no equal sign there. All right, so this has the equal sign. All right, go ahead and start on the next one. Pause the video. All right, just be careful. We got to change direction of that inequality on this one. And then because of this equal sign, then we have a closed circle here on the 2, or that should be a -2. All right, so x is greater than or equal to -2. All right, so that is solving inequalities. Just remember to change direction if what you're doing is multiplying or dividing by a negative. There we go.